Parallel lines are lines which do not meet. They don't intersect each other. So if we have two parallel straight lines, they must have the same gradient. The only thing that will be different about them is that they'll intersect the y-axis at two different places. So if we have our first straight line shown here, then any other straight line with the same gradient is going to be parallel to that. It just intersects the y-axis at a different place. So for parallel lines, we have just one very straightforward fact, which is that parallel lines have the same gradient. This means that the test for parallel lines is really very straightforward. Let's look at a couple of examples. Are these two lines parallel? Well, the first line is given to us in the very convenient form where we can just read off its gradient. Because that is in the form y equals mx plus c, we can see straight away that its gradient is 3. However, the other line isn't in such a convenient form. If it's in this form, which is quite attractive to look at, some x's and some y's and a number equals 0, nice integer coefficients throughout, but it's not very useful in terms of understanding the line, so we're going to have to do a little bit of algebra. Let's add 2y to both sides, so we get 2y is 6x plus 5. Let's divide through by 2, so we've got y is, well, 6 divided by 2 is 3, 3x, plus 5 divided by 2. Can't really do a lot better than 5 over 2 for that. But now that we've rewritten it in this y equals mx plus c form, we can see that also for this line it has a gradient of 3. So therefore we can deduce that these two lines are indeed parallel. Another example, are these two lines parallel? Well, the first one is in a form which looks very similar to what we would normally have, the y equals mx plus c form, but not quite. But there again, it only takes a moment's thought to realize that it is. It's just that the two pieces have been written the other way around. If we write that as y equals negative x plus 2, now we can see that the gradient of that line is negative 1. We've got negative 1 x's. The other line, once again, it's in this nice attractive form, but not a very helpful form. So let's do our algebra on that. Maybe we can add the 6y to both sides. 6y is 3x plus 7. Divide both sides by 6 to get y equals, well, 3 divided by 6 is a half, and 7 divided by 6 is 7 over 6. The fact is, we can now see that this line has a gradient of 1/2 because negative 1 is not the same thing as a half. Therefore, we can conclude that these two lines are not parallel. Suppose now that we have to answer this, find the line parallel to x plus 2y minus 4 equals 0 that passes through the point negative 2, 3, and we're asked to give our answer in the form y equals mx plus c. Well, if the line is going to be parallel to the one that's given, it will need to have the same gradient. So we better start off working out what that gradient is. X plus 2y subtract 4 is 0. Well, if we leave the 2y on that side, but subtract an x and add the 4, and then divide through by the 2, y is negative 1/2 x plus 2. So that means that the gradient of the original line is negative 1/2, and we are interested in using the same gradient because we want a line parallel to this, but it goes through this point negative 2, 3. So, using the idea that the equation of a straight line through a point x1, y1 with gradient m is y minus y1 is mx minus x1, we can put all that information in to get y subtract 3 is negative 1/2 of x subtract negative 2. Now that is the equation of the line, although even if I were able to leave it in this form I would have to tidy up this x subtract negative 2 thing, but we've been asked to do it as y equals mx plus c, so let's do a little bit more tidying up. We'll start off by expanding the right hand side. Negative 1/2 times x is negative 1/2 x. Now x subtract negative 2 is the same as x plus 2, and then I multiply that by negative 1/2, that would be minus 1. Now let's add the 3 to both sides. Y is negative 1/2 x plus 2. If we have two lines which are perpendicular, that is at right angles to each other, the situation's a little bit different. Here's one line, here's another line. They are perpendicular to each other. One way we can illustrate this is by showing what would happen if you start from one of the lines, turn through 90 degrees, and end up on the other line. Well, let's look again at our first line and remind ourselves what we meant when we were calculating the gradient of that line. If I pop in a little triangle, now let's zoom in on this. So, if we once again show what it's like when we rotate this through 90 degrees to get to the other line, we'll end up with this triangle here. Let's include that triangle before we rotated it. There we go. And to make things even easier to see, let's actually get rid of the lines themselves. Now if we were calculating the gradient of the original line from the blue triangle, we would have worked out the length of this line, which we've called delta y, the change in y before. We'd have worked out the length of the bottom line, delta x, and the gradient of that line would have been delta y divided by delta x. But because the green triangle is just the same as the blue one rotated through 90 degrees, we can see that the change in y of the green triangle is the same length as the change in x of the blue triangle. However, we have to realize that if we move along that line now, we will be going down as we move from left to right, so we have to think of that as negative delta x. Similarly, the length of the horizontal line in the green triangle is the same length as the delta y in the blue triangle, so that length is delta y. What does that mean in terms of calculating gradients? Well, it means for our original line, let's call it line 1, we had the gradient of that line, let's call it m1 for gradient 1, was delta y over delta x. For our second line, let's call that line 2, we had that the gradient 2 was, now this time, the change in the y coordinates was the negative of the original delta x. The change in the x coordinates was the same as the delta y from the original line. So what are we going to get if we multiply these two things together? So that will give us delta y over delta x multiplied by negative delta x over delta y. Well, the delta y's will cancel and the delta x's will cancel. We have a negative sign there. We will end up with negative 1. So here is the important part. For any two perpendicular lines, the product of their gradients will always be negative 1. Another way of thinking about this is that you could say that you could get the gradient of a perpendicular line, you can get gradient 2 by doing negative 1 divided by gradient 1. Let's use those ideas to see if these pairs of lines are parallel, perpendicular, or neither. So in both cases, what we're going to need to do is get the gradients of those two lines. All these equations are given us in the attractive to look at but difficult to work with form. So if we take the first line in A, add 2y to both sides, 2y is 4x plus 3. Therefore, dividing by 2, y is 2x plus 3 over 2. The important point is that the gradient of the first line, let's call it m1, is 2. For the other line, we've got 4x plus 8y minus 1 is 0. So let's leave the 8y there, but we'll subtract the 4x rather, I apologise, and we'll add 1 to both sides. Now we'll divide through by 8. Negative 4 divided by 8 is negative a half. 1 divided by 8 is 1 over 8. That means, therefore, that our second gradient in this case is negative a half. Now, m1 times m2 being 2 multiplied by negative a half is negative 1. Therefore, we can conclude that they are perpendicular. What about part B? Well, hopefully we're getting a bit quicker at working out how to rearrange these and seeing what the gradients are. Check this for yourself if you need a bit of practice, but in the first line you should be able to deduce fairly easily that the gradient is 3 over 2, and for the second line that the gradient is 2/3. So if we multiply these two gradients together, if we do 3 over 2 times 2/3, we get 1, but that's not what we need for them to be perpendicular, so they are not perpendicular. We can say, therefore, not perpendicular. But also, we can see that those two gradients are not equal to each other. It's very easy to see, of course, that 3 over 2 is not the same thing as 2 over 3, so therefore they are also not parallel. In this case, the answer is that those lines are neither perpendicular nor parallel. A fully formed question to finish us off. Find the line perpendicular to x plus 2y minus 4 is 0 that passes through the point negative 2, 3, and we're asked to give our answer in the form ax plus by plus c is 0, where a, b and c are integers. So we are going to need to know the gradient of the perpendicular line. Let's start off by working out what the gradient of our line is. If the line that we're starting off with is x plus 2y minus 4 is 0, then if I subtract the x and add the 4 from both sides, I get that 2y is negative x plus 4. Divide through by 2, I get that y is negative 1/2 x plus 2. So that means the gradient of the line I'm starting off with is negative a half. But I need to know the gradient of the line perpendicular to that, the gradient that we have so far called m2. So that is negative 1 divided by the gradient we have just deduced. Now dividing by fractions is horrible. It's much nicer to multiply by the same fraction but turned over. So in this case we will have a gradient of 2. So now we have a gradient and we have a point. We can use our y minus y1 is equal to m x minus x1 idea. That means that we have y subtract 3 is equal to 2 lots of x subtract negative 2. And that is the equation of the line, but we've been asked to do it in a particular form, so we'll need to tidy this up. Let's do y subtract 3 is, and I'll both simplify this part in the bracket and expand at the same time. So 2 times x is 2x. 2 times, well, x take away negative 2 is the same as x plus 2, and if we double that, we get 2x plus 4. Now finally we need everything on one side. It doesn't really matter which side we do it to. I'm going to move the y minus 3 over to live with the 2x plus 4. So that would involve doing the 2x, and then we'll be subtracting a y. We've got the plus 4, and then we'll be adding a 3. So finally the answer is 2x subtract y plus 7.
Ah, of course, those last two lines should both have equals 0 after them. Apologies for that. There we are.